Alright, so this is your homework efficiency and heat engine practice. Remember, try the problems first. So right now, pause. Once the questions come up, pause the video, attempt them on your own, and then check back for the answers. Alright, so here are the first two problems. Try them and come back to the answer. So first, Batman, tired of childcare, decides to go back into fighting crime and must throw a piano at the Joker in order to stop him from escaping. However, Batman has gotten out of shape and his muscles operate at only 10% efficiency. How much energy will Batman need to put in to lift a 400 kilogram piano to a height of 0.4 meters before throwing it? So we do know that we need some sort of efficiency equation. Most likely, we're mostly going to be using this one. Alright, if we need to figure out how much we put in so that we can figure out how much we put out. This is what we want to know. This is 0.10 or 10%. So to figure out how much work or how much, remember, work is just the addition of energy, any type of energy. So if he lifted a piano, that piano is above ground, it has a mass, you could do the potential energy. You also could have done work by finding the force of gravity times the distance. Why could you have done both? Because GP is mgh. If you'll notice, this h could be your delta x. Force of gravity is mg. So really, they're just different ways of writing the same equation. So I'll just do mgh to make it simpler. So that's 400 kilograms times gravity, which is roughly 10 meters per second squared. Then the height is 0.4 meters. Multiply that, you'll get 1,600 joules over your QH, what we don't know, is equal to our 0.10 efficiency. So to find this, you're essentially going to swap these places. So QH is equal to 1,600 over 0.1, which will give you 16,000 joules. Alright, looking at our next one, this is a more complex because now it's a bit of a combination problem. So Boston Mayor Marty Walsh recently held a press conference urging city residents to stop jumping out their windows and into the snow. Let's assume the 68 kilogram Bostonian jumps from a height of 5 meters out of her window and into the snow. If she leaves her window with a velocity of 1.8 or 1.2 meters per second, how much thermal energy will she create as the snow brings her to the stop? How many grams of snow could she melt with this heat, assuming the snow is already at 0 degrees Celsius? Alright, so our first thing is we want to find thermal energy. If we're finding thermal energy, it needs to be Q. So the idea is that the snow brings her to the stop. So if we talk about drawing a picture for this, person was at their window. They jumped down with 1.2 meters per second. They're 5 meters up. Later, they have no energy, but they did lose it as heat in the beginning. They had potential energy to fall, plus kinetic energy. This is essentially what we're looking for. Alright, so to write that out, our GPE plus our initial KE is equal to our heat lost in this process. So our potential energy would be mgh plus 1/2 mv squared, still equal to Q. Plug in your numbers, 68 kilograms, 10 meters per second squared for height of 5 meters, plus 1/2 times 68 times 1.2 squared. Alright, so if you do the math, you'll get this ends up being 3,400. This is 48.96, so I rounded it to 49. Add those up, you get 3,449 joules. So this is the total thermal energy that she created to come to a stop. So now, based on that, once we have heat, she now wants to know how much snow could she melt with this heat. Alright, so if that's our heat, we now want to think, what equation are we talking about if we're talking about melting snow? That is going to be our Q equals ml. So this equation is when we're talking about a phase change, such as melting, freezing, boiling, condensing, that kind of thing. Gas to liquid, liquid to gas, gas directly to solid, back and forth. So, they give us our latent heat, that is our L. We know the total heat, so now we can plug in and solve for our M. So we have 349 joules. We don't know our mass, but we know this is 334 joules per gram. If we divide here by joules per gram on both sides, we cross out our joules, leaving just grams. Notice, look at how nicely these numbers line up. It's going to be 10.3 grams of snow could be melted. Alright, so now these talk about heat engines. So remember how a heat engine works. You have an engine. You must put heat in, or QH. Out comes work. And out comes heat lost, or QL. So it says that this diesel engine provides 2,200 joules of mechanical work, so this is our work. Alright, and then discards, so it loses this many. So A is asking how much heat must be supplied. So if you look at your engine, you can see, oh look, I have this Q heat, this all goes in. What goes in must come out. So we have our work plus our QL. So essentially our in equals our out. So if 2,200 joules come out along with 4,300 joules, we know that in total, the energy that we put in had to be 6,500 joules. Alright, then based on this, it's asking the efficiency. And if you remember our efficiency equation, you could use either one. I think the easier one is the one we've been working on, which is efficiency is equal to work over QH. We now know our work, or we knew our work to begin with, over our QH that we found, our heat in, and divide. Alright, and then you'll get 0.338, or you could have rounded to 0.34, or 34%. Hopefully this is not too much work for you guys. It's only about 2,200, so I think you'll be okay. Alright, and we'll just do one more. So a Carnot engine whose high temperature reservoir is 620 K. This is Kelvin, by the way. Takes in 550 joules of heat at this temperature in each cycle and gives up 334 joules to the low temperature reservoir. Alright, and I just realized this is a Carnot engine problem. We're not going to cover these in this class, so don't worry. Go ahead, do number 7, don't worry about 6. I will not put a Carnot efficiency problem on your test. So this says our efficiency is 40%, or 0.4 would be our efficiency. Then it says this are taken into the engine. That would be our QH. And it says how much energy leaves as exhaust heat. This would be our QL. So we want to find QL. So to find QL, we're going to want to use this equation, which is the 1 minus QL over QH. So we know efficiency is 0.4. 1 is just 1 minus our QL, which we do not know yet, over our QH, which is 5,000 joules. So first thing you should do is get rid of things near your variable. So get rid of this 1. Subtract, that'll give you a negative 0.6 is equal to QL over 5,000. Now multiply both sides by 5,000. And you will get QL is equal to, this is 3,000. Oh, and if you're wondering where the negative sign went to, this was negative and then this was negative. So essentially they can just cancel out, or these both would be negative, therefore they could also both be positive as well. Alright, hopefully this is informative. Make sure if you have not yet finished your outline, if you have, disregard, but if you've not finished your outline, make sure you have your outline and your 7 sources as soon as possible.